Thank you. Next slide, please. I appreciate that introduction, and I appreciate all of you being here this morning. Next. So in this webinar, we're going to cover a number of things, including we're going to look at the manufacturing process for fire retardant treated wood, including how fire retardants are integrated into the wood products, offering a durable layer of protection. We're going to talk a little bit about the mechanics of fire and the way that fire retardants work within the mechanics of fire to break the combustion cycle. We're going to discuss how to identify and correctly specify fire retardant wood products. Next, please. We will identify some of the common interior and exterior applications for fire retardant wood products. We're going to look at some code mandated testing standards that are required to confirm that the fire retardants actually work. We're going to talk a little bit about where fire retardant wood is referenced within the codes. And we're going to talk about some construction market shifts that I've noticed that could impact demand for fire retardant wood products going forward. There's a lot of information here and almost 70 slides. So what I'm going to do is run through some of them very quickly to keep us on schedule. The presentation itself will be made available to everybody in the webinar. So if anybody wants to dig a little deeper into some of the slides that I kind of glossed over, you'll be welcome to do that at a later time. Next, please. First, we're going to talk just a general introduction to fire retardant treated wood. Next, please. So everybody knows wood burns, and that's just a fact of life. People have been using wood to heat their homes and cook their foods for a long time. Not long after that, they began using wood to build things as well, which is kind of ironic. This burning material is something that they're going to shelter themselves in. But wood's really a remarkable building material. It has a really high strength to weight ratio. Its cellular structure is such that it allows it to bend without breaking and withstanding lateral forces like earthquakes and high winds. So it's very resilient in that way. And it also stores atmospheric carbon, which makes it an important tool in fighting climate change. So it's got a lot going for it, but yeah, it burns. So to address the burning part and expand ways that wood can be used in construction, so technology has been developed to help make wood less susceptible to fire by impregnating it with protection. And that's what we're going to be talking about today. Next, please. The building codes recognize the effectiveness of those technologies. And those are the basis. The International Building Code is what I'm going to talk a lot about today. This is the basis for virtually every local jurisdiction building code in the U.S. The IBC delineates specific construction applications where fire retardant treated wood products can be used in place of non-combustible materials. And we're going to talk a little bit about those applications later in this presentation. Next, please. Fire retardant wood products can be used, are available as both interior use and exterior use, and they can be used with other materials to create fire-rated assemblies, which are the required by the codes. Interior applications for fire retardant lumber and plywood include walls, roofs, subflooring, interior paneling, etc. And when we talk about interior, we don't necessarily mean inside the building, but really what we mean is in applications where the wood is not exposed to the weather. So the interior section of walls, for example, includes interior. Conversely, exterior means any application where the wood is exposed or partially exposed to the weather. So some of those exterior applications would be roofing, like shakes and shingles, exterior cladding, decks, balconies, bay windows, etc. Next, please. Really quickly, I'm going to talk a little bit about the history of fire retardants. I won't spend a lot of time on this, but I just want to give some background to it. Next, please. So the idea of protecting wood from fire goes way back. The Vikings used to char the hulls of their boats to keep them from burning, very much like It's a there's a Japanese finish used today for the kind of same reason. The char layer that gets formed actually protects the interior wood from being burned. That's kind of just how wood burns. But it was in 1821 when the first guy came around to using chemistry to develop fire protection formulations. His name was, and I'll probably mispronounce it, Joseph Gay-Lussac, or something like that. You can read it yourselves and tell me if I'm right. He was the first guy to put together chemical formulations that could be applied to wood, textiles, and other materials. His treatments featured ammonium phosphates and borates. Those are compounds that are still found in fire retardants today. A little later on, almost a century later, in the late 19th and 20th centuries, there were some really tragic fires that occurred in the U.S. where lots of people were killed, and that raised demands for development of building codes to protect people. Prior to that, there were no building codes. People built things just the way they thought they should, and consequently, it didn't always work. So the development of building codes then sparked a lot of R&D that was aimed at developing fire protection technologies that were better than what was available at the time, so that wood could continue to be used as a primary building material. And by the 1930s, the U.S. Forest Service, or the U.S. Forest Products Laboratory, which is part of the U.S. Forest Service, had researched more than 130 different fire retardant formulations to confirm their effectiveness. Next, please. So the fire retardants that are available today really represent the culmination of more than a century of research. All fire retardants used in pressure treating today share characteristics in retarding the effects of fire. In other words, they're all the approved fire retardants meet a certain minimum standard of being able to retard fire or resist fire. But each one of them is a proprietary formulation and is marketed under a specific brand name. The fire retardant chemical manufacturers provide certificates, code-required testing, and third-party inspection requirements that their products adhere to. They also provide specific product use information for wood treated with their formulations, including strength calculations, which vary from manufacturer to manufacturer. The process of pressure treating wood with fire retardants actually causes the wood to be slightly weakened, and depending on the retardant and the product, et cetera, the amount it gets weakened varies. So we'll talk a little bit more about that later as well. Next, please. So now we're going to jump into mechanics of fire and just how the fire retardants work. Next, please. Fire is basically just a chemical reaction. It requires three things: oxygen, heat, and a fuel. Next, please. Wood can be the fuel, and when exposed to high heat or fire, the cellulose and lignin that comprise wood actually convert into flammable gases that mix with oxygen to feed and expand the fire. The chain reaction kind of feeds on itself and creates a combustion cycle, which generates more heat and increases the release of the flammable gases until the wood is broken down into smoke and ash. That's what happens normally. If you don't get rid of one of the oxygen or the heat, the wood's going to eventually burn into ash. Next, please. So what fire retardants do is they alter the chemical makeup of the fuel. You're ahead of me by one, it looks like. The wood been impregnated with these fire retardants, and instead of releasing those flammable gases, that releases carbon dioxide and water vapor when it's exposed to high heat. That helps to reduce the combustibility of it, and without those volatile gases, the fire is robbed of its fuel and the continued heat needed to maintain the combustion cycle. The retardants also react with combustible gases and tars, which helps to form a char layer, carbon char layer, and that char layer protects the interior fibers of the wood and attempts to insulate the wood below. Now, all wood burns that way. All wood forms a char layer and attempts to protect itself from the fire. And if it's thick enough, often it'll form a thick enough char layer to survive through the entire fire. What the fire retardants do is simply expedite that process. The it basically creates a durable layer of protection. Okay, next, please. The building code sets specific standards and testing protocols to confirm the protective quality of the fire retardants. And these tests are used to assign what's called a flame spread rating and smoke development ratings for wood, and they use those ratings for all sorts of different products. Fire retardant wood achieves a Class A, which is the highest grade of these flame spread ratings. Class A rating, same thing as drywall. It's basically the same flame spread rating as drywall. Unprotected wood typically will have a Class B or a Class C rating, which are significantly lower ratings in terms of fire resistance than the Class A rating. Next, please. So fire protection measures, the fire protection measures required by the code are not designed to make structures fireproof. Instead, what they're designed to do is provide sufficient time for occupants to exit the building and for first responders to safely enter the building and fight the fire for a period of time. The fire retardants do not make wood non-combustible. Instead, they delay combustion sufficiently to meet these code requirements. It's important to know that if it's exposed to flame for a long time, fire retardant wood will eventually burn. Those fire retardant materials that convert into the carbon dioxide and water vapor ultimately run out, and now you're left with just wood, and the wood will burn. It's just a delayed period. So next, please. We're going to talk now a little bit about how fire retardant wood is made. Next, please. Pressure treating is used to produce fire retardant wood as well as preservative wood. It takes advantage of unique characteristics of wood to create a protective shell around the lumber or plywood. Basically protects all of the wood from the fire for a period of time. The pressure, which is applied in a vacuum, forces the fire retardant chemical to fully penetrate the wood cellular structure, which gives it its lasting protection. There are a variety of fire retardants used today. All of them are applied to the wood in essentially the same way. The differences basically are how long does it have to be in the cylinder, and how much pressure is needed to get that retardant into the wood. And that also is dependent on the wood species as well as the formulation that's being used. Next, please. As I mentioned before, the International Building Code essentially defines what fire retardant treated wood is and what fire retardant treated wood isn't. Section 2303.2 of the code defines fire retardant wood as any wood product that, when impregnated with chemicals by a pressure process, achieves this. And then it later further clarifies that. We'll talk about this again by saying the use of paints, coatings, stains, and other surface treatments is not an approved method of protection as required in this section. And this section is essentially identifying, defining things that can be used as fire retardant wood in construction processes that are defined later in the code. Next, please. So the steps that are taken, it starts with untreated lumber or plywood. The untreated lumber is loaded onto carts, which are moved into a specially made pressure cylinder. It's called a retort. While the wood does not need to be fully dried prior to treating, but its moisture content has to be low enough to meet the fire retardant manufacturer's requirements for proper use of their product. That might be 25%, might be 30% moisture content, something along those lines. It can't be completely green. It has to seasoned to some degree. For fire retardant wood, incising is not required. You might know that incising is required in many cases for Western species when applying preservatives, but that's not the case for the application of fire retardants. Now, these retorts, these cylinders, they can be up to 150 feet long, and they're sealed, and a vacuum is applied to remove all the air from the chamber. Once that happens, the liquid fire retardant solution is pumped into the storage tank, completely filling the tank. Pressure is then continuously applied for a period of time within the retort to force that fire retardant solution into the cells of the wood. Next, please. Processing time varies, as I mentioned earlier, and it depends on a number of things: the wood species, the size and type of the product, the fire retardant being used, and what the application is going to be, whether it's interior or exterior. At the end of the pressure cycle, the fire retardant solution is drained from the retort, and a vacuum is used to return the excess solution to storage tanks for future use. The wood itself is pulled out of the retort and left on a sealed drip pad that catches anything that might drip off that wasn't pulled out by the vacuum. So we can reclaim any residual material and not have it leach off into the environment. Next, please. Now, the building codes require that fire retardant treated wood be dried after treatment. Lumber needs to be dried to 19% or less moisture content, and plywood needs to be 15% or less moisture content. And also to ensure quality, all the treating facilities have quality assurance programs in place where they essentially take core samples, analyze those samples to make sure that the fire retardant was impregnated the wood properly, to make sure the wood's the right moisture content throughout, et cetera. And then there are third-party inspection agencies that visit periodically and inspect the mill's quality control procedures and practices and make sure that those are actually working, and that in fact the product that they have on the yard for sale meets all those codes and standards that are needed. Then the finished fire retardant wood products typically are wrapped for protection during shipping. Next, please. All fire retardant formulations are proprietary, as I mentioned before, but they still all must meet standards and certifications defined within the building codes. The American Wood Protective Association sets defined standards for the treating process as well as for the treatment chemicals. Most commercially available fire retardants also have ICC-ES reports or ESRs, which detail their properties and other essential information. And the ESR number is shown in the quality mark that's required to be placed on the fire retardant wood products. And I'll talk about those quality marks in just a minute. And again, then there's third-party testing organizations such as Underwriters Laboratories or Intertech, et cetera, who often are used to confirm that what the company, what the treater or the fire retardant chemical maker says about their product is in fact true of the product itself. So they'll test the products and then certify that that they do what the company says they'll do. Next, please. So we're going to talk a little bit about the two kinds. We mentioned this before, but I just wanted to emphasize it here. Next, please. There's two different kinds, interior fire retardants and exterior fire retardants, and they're designed to meet specific needs. Though fire retardant treated wood that is intended for interior use is not suitable for exterior use. You must use exterior rated fire retardant wood for exterior use in order to make sure that it performs to the degree it needs to perform. So there's, like we mentioned a little bit about what different applications are, et cetera. But it's definitely important that people understand that just because it's fire retardant doesn't mean it's going to work as exterior decking, for example. Next, please. So this slide shows you some of the common uses for interior rated fire retardant. It's essentially lots of different areas where the wood is protected from the weather. Let's see here. You can use it to construct walls, fire stops, partitions, all the stuff that's inside the exterior cladding of the building. Next, please. And as you might expect, there's a number of applications for exterior uses, all of which are outside the building: balconies, decks, cladding, construction staging, scaffolding, eaves, soffits, storefronts, et cetera, et cetera. Lots of different uses. Next, please. So the IBC specifies certain testing that is mandated for fire retardant treated wood products. to ensure that they actually do what they say they're going to do. I've listed a few of those here. ASTM E84 or UL 723 is a flame spread test. Now, in 2021, the IBC added some requirements to these test procedures, and I've highlighted on this slide and the next slide what those additional test procedures are. They added not only do you have to do a ASTM E84 test, but you also have to continue that test for an additional 20 minutes and make sure that the flame front doesn't progress more than 10.5 feet beyond the center line in that testing. And next, please. And then with plywood, the testing has to be done with a longitudinal gap of 1/8 of an inch ripped into the plywood. And the reason for that is that when in the real world, when you put plywood up on the side of a building, it never is completely flush. There's always a gap between the pieces of plywood, and plywood, like all wood, will move a little bit. So that gap could increase or decrease depending on which way it moves. And so to make sure that it actually does the job properly, they have to try to mimic the real world. And that's why that 1/8 of an inch cut is not required in the testing. Next, please. For exterior fire retardants, there's another test required. That's ASTM D2898, which is an accelerated weathering test. This test basically exposes the wood to the equivalent of 800 inches of rain over a 12-week period. So that's a lot of rain during a 12-week period. I live in Portland, Oregon, and that's like 20 times as much rain as we get. So that gives it a pretty good test. And that's to make sure that the fire retardant formulation doesn't get washed out of the wood by the rain. It stays in there despite what the weather does to it. Excuse me. Next, please. So one common question that we get is whether or not fire retardant treated wood provides any preservative protection as well. There are no approved products treated with both preservatives and fire retardants, but some of the ingredients that are used in fire retardant formulations are the same as some of the ingredients used in preservative treatments. For example, fire retardant formulations contain borate, most of them do, which is also used as a preservative in interior applications where wood is protected against weather. So in some cases, the fire retardant wood can provide preservative protection for the wood to a certain degree, and the manufacturer normally will tell you what to expect in that regard. The manufacturers also all carry limited warranties for their products, and the details of those are manufacturer by manufacturer, but they're generally warranted for quite a while to actually work the way they're supposed to. Next, please. Okay, so specifying wood in construction. Next, please. So the keys to proper specification is knowing what the fire retardant treatment is, interior, exterior, etc. Understanding the approved quality marks, knowing what the strength adjustments are, and knowing how these products are used in fire-rated assemblies. So I'll go into a little bit more of that here as we go forward. Next, please. What's going on here? Okay. So as I said before, this is kind of a repeat of what we said before, but we think it's important. The building code has a specific definition of what fire retardant wood is. And that definition talks about how the product is made. And also it specifically states that spray-on coatings, paints, stains, etc., are not approved. And those just simply do not penetrate the wood all the way through. And so if the fire were to burn through the coating, or if the coating were chipped or anything like that, the level of protection wouldn't be there. And that creates a really dangerous situation. And so that's why that sentence is in that language is in the code. It was added to the code in 2018. Next, please. Fire retardant wood is required to have a quality mark on the wood. And these are the elements that quality mark has to include. It's going to tell you what the fire treatment is. It's going to identify the manufacturer. It's going to tell you the species of the wood. It's going to tell you how it was dried after treatment. It could be kiln dried or air dried. It's going to have an identification mark of an approved inspection agency that inspects the mill. It's going to tell you what the flame and smoke development index is. And it's going to tell you that it conforms to the standards that the IBC sets out. Next, please. When it's stamped on the wood, it's going to look something like this. Next, please. And then for exterior fire retardant, it's going to require all those same things that are required on the interior stamp, but it also has to have this added language: no increase in the listed classification when subjected to standard rain test ASTM D2898. It has to state that. That's how you know the difference between the exterior and interior fire retardant wood. Next, please. So fire retardants that are used in fire and pressure treating, they're colorless typically, and they don't change the appearance of the wood. So you can't look at a piece of wood. An untreated 2x4 is going to look almost exactly like a treated 2x4, and it won't be any way to tell except that stamp. Now, some treaters, in order to make it easy on the job site, will add color tints, or they'll place markings, or they'll have a colored chalk line or something like that on the fire retardant wood, so that the guys on the site can easily, choose the right wood for the right application. But you cannot depend on the color to tell you that that's fire retardant wood, because some manufacturers of those paints and coatings that are not code compliant also use color to differentiate their products from unpainted product. And so really all you can depend on is that stamp. The stamp tells you if it's fire retardant. That's the only way to know. Next, please. So I mentioned earlier that the process of treating wood with fire retardants reduces the strength of the wood slightly. And so there are structural tests that the code requires be made with fire retardant wood. So after you treat your wood, you got to go have your wood tested to see how strong it is and how strong it is compared to that same wood, but prior to being treated. The reductions in structural properties can range anywhere from like 2% to 25%. And it really just depends on the specific species, the use conditions, the product, the sizes, the thickness, etc. So because all the formulations are proprietary and different from one another, each fire retardant formula manufacturer has its own set of strength reduction tables that need to be used. So when you're specifying with this stuff and trying to design, know that the wood's not going to be as strong as it was before. But in order to know just how much less strong, you need to contact the guy who made the formula that it was treated with, and they can provide you the reduction tables for all the different species and sizes, etc. Next, please. So I want to emphasize this again. Fire retardant wood products provide protection that's expressed as a flame spread rating and or a smoke development rating. These are not to be confused with the fire resistance ratings of assemblies, which are expressed in time units in the building codes. So a fire retardant treated wood, 4x4, doesn't in and of itself have a 1 hour or a 2 hour rating. All it has is a flame spread rating. That piece of wood needs to be used in an assembly of other materials to provide an hour, a time-based rating for that entire assembly. So by assembly would mean like a wall or a floor or anything along those lines. Now the fire retardant manufacturers, most of them have put together assemblies that utilize their products and had those assemblies tested for the fire retardant resistance of 1 hour, 2 hour, etc. And they'll provide those to you. And you see an example here, and I've highlighted here which parts of it are the fire resistant wood, and which you can see everything else is just not. It's insulation and cladding and drywall and things along those lines. Next, please. Additionally, the American Wood Council has put together generic assembly designs that have been tested and are allowable under the code. And these can use any code compliant fire retardant treated wood. So these are the generic means by which to achieve the rating that you would need to achieve to meet whatever the code requires. What's pictured here is type 3 exterior bearing wall, which requires a 2-hour fire rating. And this is specifically a 1-hour floor assembly intersecting with the exterior wall that has to have a 2-hour rating, and how to put that together so that both retain the fire ratings that they need to retain. Again, I've highlighted on this slide where the fire retardant wood is. But as you can tell, these things can get complicated because there's all sorts of different assemblies that are required to build a building. And it's important to know how the fire retardant wood fits within those assemblies to achieve the ratings you need. Next, please. So more about how fire retardant wood fits within building codes, et cetera. We have published, and it's available on our website, a spec sheet. It's pictured here about fire retardant wood in the 2021 International Building Code. And I probably should have mentioned this before. The International Building Code is for commercial structures. It's not single family residential. There's a separate International Residential Code, which addresses single family residential. What we're talking about today is the International Building Code, commercial construction. But the fire retardant wood operates in the same manner within the residential code. It's just the residential code has different requirements. So anyway, the building codes provide this basis for what the stuff is, and it tells where it can be used as a substitute for non-combustible materials in commercial, industrial, institutional, hospitality, multifamily, et cetera, all sorts of types of construction. Next, please. This presentation has a list of most of the actual direct references for where fire retardant wood fits within each type of construction. There's a lot of them. We don't have time for it. I'm going to really quickly go through each of one of these and just mention real quickly. So this list is for type 1 and 2 construction, interior uses. Next, please. Then exterior uses for type 1 and 2 construction. Next, please. Then type 3 construction. Now this is one of the more common types of construction, and it requires a 2-hour rating, assemblies with a 2-hour rating for the exterior walls, and this represents like 5 to 6 story apartment buildings. It represents fourplexes. It represents smaller office buildings, 6-7 story office buildings. It's the bulk of the construction that goes on today. Next, please. Type 4 construction used to be known as heavy timber construction. It's now known as heavy timber and mass timber construction. And in 2018, a huge number of significant changes were made to type 4 construction codes. They're adopted in 2018 for the 2021 building code. And there are far too many of them for me to go through today. In fact, AWC has a 1-hour presentation focused only on those changes in the type 4 mass timber codes. That they spend an hour doing that, and they probably don't cover it very well or completely in that either. Next, please. Now, within buildings, there are structures built within buildings like stages and schools and things like that. Fire retardant wood can be used in those, like platforms, et cetera. Next, please. Also, freestanding kiosks inside of malls, for example, children's play structures. You can start to think about all these different things that might be within a building, where the building has one type of fire protection, but the thing in the building also needs to be fire protected for a fire that might be inside the building. Next, please. Exterior wall coverings also often are wood, and commercial buildings like to use wood. There are rules around that. And most of these places where they say you can use it, there's also exceptions. So you need to pay attention to the exceptions as well. Next, please. And then for exterior, like we mentioned before, balconies, bay and oriel windows, et cetera. Next, please. Roofing, shingles and shakes for roofs. Next, please. And then freestanding canopies, like at a gas station, for example, the structure that is over the gas pumps can be built with wood. It would use fire retardant treated wood to do that. Next, please. So looks like I'm doing okay on time because I'm nearing the end. So I want to talk a little bit now about some construction market shifts that I've seen that I think will affect or are already affecting demand for fire retardant treated wood. Next, please. So the first one is for quite a while now, there's been a steady shift in the residential construction market where multifamily construction represents an ever-growing portion of the overall number of units being built each year. It used to be about 70% of all residential construction was single-family homes, and 30% or so was multifamily, like apartments, condominiums, that sort of thing. I think that's reversed almost completely. I think it's now about 60% multifamily and 40% single family. So the result of that is a reduced demand for wood products as a whole on a per unit basis. It takes less wood to build 4 units in one building than it does to build 4 houses. But it also means an increase in demand for fire retardant wood because many of the multifamily structures are 5- and 6-story type 3 wood frames, and those require a 2-hour rating, which can be achieved really economically using fire retardant treated wood. There's really no sign that this trend is going to reverse itself anytime soon. I think it's going to continue in the direction it's continuing. It's probably going to be more like 75-25 eventually. And a couple of reasons for that. First of all, we're running out of really buildable space you can't just keep expanding and fill all the land with houses. And second of all, people more and more want to live in urban areas, and there's really not a whole lot of room in urban areas. So the best way in urban areas is to grow up, not out. So that trend looks like it's going to stick around, and that is a boon for fire retardant wood. Well, it's not such a great thing for just wood, but we'll replace that with mass timber or something like that. Okay, second, mass timber construction is another opportunity, in my opinion, for fire retardant wood. Not everyone totally agrees with me. Mass timber still, while it seems there's a lot of talk about it, and it's really popular and it's growing very rapidly, it still represents a very small percentage of the overall commercial construction market. But I believe that percentage will continue to grow and will get bigger and bigger. And the thing about mass timber construction, they get their fire ratings for the structure, et cetera, from the mass timber itself. That's one thing about mass timber. It's really big and it burns, it forms a char layer, and the char layer protects the wood, and the building stays standing long enough for the guys to get in there and fight the fire and get everybody out. So they don't need fire retardant wood for that purpose. However, interior partition walls and things like that in tall buildings generally need to be built with fire retardant wood or other non-combustible materials. And a big impetus behind the growth of the mass timber industry is that wood is an environmentally sound choice. It stores carbon. It's a potentially a really good tool for fighting climate change. And so the designers and the developers who have kind of locked on to mass timber as the way to go are doing it for that reason, because wood is good. And they see wood as a better material than the other materials for building these tall buildings. As a result, their tendency is to think about using wood wherever they can use wood in place of these other materials. So even though steel studs might be cheaper than fire retardant studs for interior partition walls, some folks are saying that's not my ethos. My ethos is to use wood. I'm going to use wood instead. Now, the image you see here is Carbon 12. That was the first 8-story mass timber building in the U.S. The developer is here in Portland. The developer of that project is Ben Kaiser, and he told me exactly that he selected fire retardant treated wood over steel, despite steel being significantly less expensive, specifically because of the wood is good ethos. He couldn't see building a building out of wood for sustainability reasons and then putting less sustainable materials on the inside of that building, and so used wood on the inside. And so I think more and more folks are gonna do that. Okay, third, the wild wildland urban interface building codes. There's more and more states are beginning to implement building codes that address buildings that are going to be in the woods or in that area where the woods, the wildland, and the urban come and they meet. That's the wildland urban interface. A lot of the wildfires that wind up, consuming a lot of people's homes are in these wildland urban interfaces. And so states are starting to realize, hey, we got to start building differently. Those building codes they heavily favor non-combustible and fire retardant materials. Most of the state level codes have not yet been finalized and implemented, but it stands to reason that when they are, the wood that's not fire retardant stands to lose market share. And it's possible that it will be replaced instead by fire retardant treated wood. So you can keep an eye on that, see what actually happens within those codes. The American Wood Council is still fighting to keep untreated wood in many of those applications. We'll see how the dust settles in the end. Next, please. So that's also starting to drive some new product developments that are out there. There are places now where the building code requires fire ratings as well as preservative, some level of preservative treatment. And so companies are trying to figure out how to do that, because as I mentioned earlier, there are very, very few companies that have attempted to put both preservative treatment and fire retardant treatment into the same piece of wood. It's very difficult to do. It can be done, I'm told, but hardly anybody does it because it's so difficult and expensive, and nobody would want to buy it. But there are other developments happening. Thermally modified wood. This is wood that's been heat treated in the absence of oxygen. That process chemically changes the wood fiber and makes it unpalatable to the microbes and the insects that degrade untreated wood. Thermally modified wood also is able to be treated. You can treat it with fire retardant successfully. And so we have this wood now where it fights decay and insects, also can be fire retardant. At least one WWPI member is marketing a fire retardant treated thermally modified wood product in areas where both decay resistance and fire resistance are required. We got a call a month ago or so from a builder who, had his arm, he didn't know what to do. He needed pressure treated wood for siding that also had to meet a fire resistance code, a 1 hour fire rating, and that didn't exist, he thought, but it turns out that it did exist, and this member was able to help him. At the same time, many of the fire retardant treated fire retardant chemical manufacturers are looking for ways that they can enhance the preservative properties of their formulas, or find ways that they can add preservative treatments as well as fire retardant treatments into the wood. And so though there's R&D going on, they've hinted that those things could be coming. And if and when they do, then that makes a fire retardant product that can be used in decks. That changes the game, especially in woolly areas where, if they eliminate wood decks from woolly areas, this product might bring it back. Okay, next, please. I've got a number of questions that we hear quite often. Before we get to your questions, I thought I'd run through some of these. So anybody is free to stop me at any moment when it's time to turn it over to asking the people the questions, but I'm going to jump into some of these because maybe they're the same questions. So what chemicals are used? They're all proprietary. They all have similar ingredients. Boron normally is one. They're all waterborne. And often the manufacturers have like third-party certifications like Green Guard that will reflect the safety of their, or that will certify the safety of those formulations. The compounds that are used in their formulations are available in their technical guides and safety data sheets. Next, please. Do we need to use different fasteners with fire retardant wood like we do with preservatives? And the answer is no, unless it's exterior. The compounds in fire retardants are not corrosive, so pretty much any common fastener can be used for interior use. For exterior uses, though, the code requires code-approved fastener materials that are the same as those defined for pressure-treated wood. Hot dip, zinc-coated, galvanized steel, stainless steel, silicon bronze, copper, those types of things for exterior. Next, please. Do I have to do anything special in regards to storage with fire retardant wood? And the answer is yes. And I would say yes, sort of. Fire retardant wood should be kept dry, just like a lot of wood should be kept dry during transit and protected against the exposure at the job site. So you may need to cover the bundles. You might need to elevate them to avoid contact with the ground or other surfaces where water can collect, etc. If it gets wet in storage, then you need to allow time for it to dry before you enclose it inside a building. Next, please. Is it safe to handle? And the answer is yes. There are no special precautions needed for handling fire retardant wood. Common sense steps for working with any kind of wood would be to use safety glasses to avoid splinters, get sawdust getting in your eyes, wear gloves to avoid splinters, use a mask to avoid inhaling wood dust when sawing or sanding. But none of those things are required. There are no special safety precautions required for handling fire retardant wood. Next, please. Can I paint it, stain it, etc.? The answer is it depends. You got to check with the fire retardant manufacturer to see what they recommend. Some say it's okay. Some say you shouldn't do it. Some say the flammability of the paint or stain will be an important factor as the film forming finishes, such as paint, can contribute to prolonging a fire, and that might impact how effective the fire retardant is. Next, please. Field treating. With preservative treated wood, you've got to treat the ends, cut ends, and holes you drill, etc. Otherwise, the preservative might not work because it could rot from the inside out. Insects could eat it from the inside out. Not the same with fire retardant wood. Fire retardant permeates the wood completely, so you can cut it, you can drill it, and you don't have to do anything special in the field. What you cannot do is rip longitudinally or mill fire retardant lumber in the field, because that could affect the burning characteristics. You can rip fire retardant plywood, but you basically have to keep it dimensionally the same and use it that way. You've changed the way it is, and you take a 2x4, you run it through a planer or through a molder and turn it into crown molding or something like that. That's going to change. It's no longer going to be a 2x4. It's going to be a whatever by whatever. And that means it's different products, so it might not have the same fire retardants. So at the end here are some resources that are available. I'm not going to run through them all. If you want to click through them, you can click through them. It's our website. We've got online courses. There's a list of fire retardant manufacturers on the website. I think we got about 10 minutes left for questions, so I'll stop talking until somebody asks a question.